So we're into the last video of section 5.4, and we haven't done any examples yet with double angles. So that's what we're going to do now. You shouldn't be too worried though. They do work similarly to the other examples. So let's just get right into an example. We're going to say that we want to calculate a couple things. So for this whole problem, we're going to have a couple parts. For this whole problem, I'm just going to say given that, let's do sine of theta equals, we'll do 7 over 25, 25. The other side should be 24. Okay. We're going to determine, let's do sine of 2 theta. Okay, so this is sine of 2 times theta. So let's go ahead and take a look at our formulas here, our identities. We're at the top of the double angles, so we're doing 2 times sine of theta times cosine of theta. So that's where we're going to start off with. We know that this equals 2 times sine of theta, which is good. I know what sine of theta is, and then times cosine of theta, which I don't know yet, but it shouldn't be too bad to find. So it's 2 times this, which is going to be 7 over 25. And that makes this 24. So if you do 25 squared minus 7 squared, and then you take the square root of that, you get 24. So that means that cosine of theta is going to be 24 over 25. So now that we have all the pieces, we're just going to go 2 times 7 over 25 times 24 over 25. I don't know this off the top of my head, so let's go ahead and use the calculator. 2 times 7 times 24 is going to give me 336. And then 25 times 25 is going to be 625. And that's the final answer. So we're all set. Okay, so like I said, it's not too much different. It's actually probably a little less work because you only have to make one triangle in order to calculate this. Oops. So it works out pretty similarly. Let's do the same for cosine now. So we're going to do cosine of 2 theta. Now cosine's a little bit weird if you look at the formulas. There's 3 alternate versions. Cosine squared minus sine squared, and then there's 2 cosine squared minus 1, or 1 minus 2 sine squared. The reason that we have a lot of different options for this is that sometimes one might be more useful than the other, although it really doesn't matter too much. There's the way that these are derived is by using the Pythagorean identity. If you use cosine squared plus sine squared equals 1, you can get those alternate versions. So in this case, if we had just been given this first part, what's nice about the cosine double angle identity is you don't even actually have to draw the triangle. Once you have sine of theta, notice I can use the third form, 1 minus 2 sine squared. Or if I want, so I could use 1 minus 2 sine squared of theta. Or I could just, since I have the triangle, I could go cosine squared of theta minus sine squared of theta. If you don't want to have to deal with multiple versions of a formula, you really don't need all 3. You can always use the one I just wrote. So let's go ahead and use the sort of easier one. If we hadn't had to draw the triangle already, we could just plug 7 over 25 in. So we would just end up with 1 minus 2 times 7 over 25 squared. So it's sine of theta, and then we square it. So I end up with 1 minus 2 times 7 squared is 49. 25 squared is 625. And now we're just kind of dealing with some fractions here. 98 over 625. I don't know what this is off the top of my head. So this ends up being 527 over 625. So what I did is I took the 1 and I turned that into 625, and then I subtracted 98 from it. So I'm trying to do some review of fractions here, but hopefully at this point you've refreshed your memory on it and you're not too worried about it anymore. All right, so we did cosine and a sine. Hopefully that was pretty familiar from the previous sections, the previous videos. Let's go ahead and also do a tangent, just because tangents get a little bit tricky. And I'm also going to use this as an opportunity to do another square root example to show you how to rationalize again. So a big part of this section, while we're paused here, a big part of this section is really just simplifying. It's a really good chance to kind of boost up your skills on simplifying radicals and also simplifying fractions, which to me are not the most essential skills, but it's really helpful if you're quick at that. It just makes problems later on go a lot more smoothly. The calculators can do a lot of this for you, but it just helps if you're already pretty fluent at simplifying and rewriting expressions. The example I like to use is if you are getting in the car to go drive to the grocery store, you don't want to have to open up your GPS every single time and have to look up the directions. It's nice to just kind of have that memorized and know how to get to the common places in town. So that's kind of the reasoning behind what we're doing here. Okay, so let's go ahead and let's determine the value of tangent of 2 theta, given that cosine of theta is 2 over the square root of 5. Okay, so the first thing to do, pretty much every time in these problems, the first thing is to write down what the formula is. So there's the formula for tangent of 2 theta in the bottom left. So I'm going to get, I looked at it and I didn't actually think about it when I did. So I'm going to have 2 times tangent of theta over 1 minus tangent squared of theta. So this tells me that I need to know what tangent of theta is, and I don't yet. I only know what cosine of theta is. So that means I'm going to have to draw my triangle. We get 2 over the square root of 5, which means that this over here is going to be 1 because the square root of 5 squared minus 2 squared is 1. So that tells me that tangent of theta is actually 1 over 2, which is nice because that actually eliminates the radical. All right, so let's go ahead and plug that in now. 2 times 1/2 over 1 minus 1/2 squared. So this is going to give me, in the numerator, 2 times 1/2 is just 1. 1 minus, so 1/2 squared is just going to be 1/4. Essentially what I'm doing here is using this property of exponents. So then I end up with 1 over 3/4. If we multiply the numerator by the reciprocal of the denominator, we just end up with 4/3. So that one was kind of nice. We started with a radical, but luckily at the end we did not have a radical, so that worked out really well. Okay, let's try another one. Let's do, I feel like I haven't done enough tangent examples. Let's try another one out. Let's do determine tangent of theta given that sine of theta equals 1/2. Okay, so once again, we'll go ahead and, tangent of 2 theta. Once again, we'll go ahead and write down our formula. 1 minus tangent squared of theta in the denominator, 2 times tangent. So this shows me again I need to know what tangent of theta is. So we'll take our information here and draw a triangle. Hopefully this is becoming kind of second nature. In these problems, you really just have to draw the triangle every single time. So here's what we're going to do. We have 1 and 2. I need the adjacent side. We could get that by going square root of 2 squared minus 1. And now, unfortunately, in this one, we are going to have to deal a little bit more with radicals, but it'll be good practice. So tangent of theta is going to be 1 over the square root of 3. Now, in order to make this just a little bit easier, we're going to rationalize the denominator. So this is what we did in a previous video. If we multiply the top and the bottom by the square root of 3, we end up with the square root of 3 over 3. And so this is actually what I'm going to use for tangent of theta. Okay, so here we go. 2 times tangent of theta, square root of 3 over 3. 1 minus tangent of theta, squared. Now, I do want to pause for a moment here because I really haven't emphasized this enough in these videos. This is the answer. It looks awful, and that's why we usually go a few steps more and try to make it look a bit nicer, but this really is the answer. This is the trig part of the problem done with. The rest of it is just using square roots and fractions. Okay, so in the numerator, it's 2 times the square root of 3 over 3. That ends up being 2 times the square root of 3 over 3. In the denominator, I have 1 minus, now this square root of 3 squared over 3 squared turns into that, 1 minus 3 over 9. Let's take this a step further. In the denominator, we now are going to have, so 1 is, this here is really 1/3. So let's just do 1 minus 1/3. So that equals 2/3. Now I'm going to multiply the numerator by the reciprocal of the denominator, so 3 over 2. And I mentioned this in a previous video. This is going to end up being a 3 divided by a 3. So this 3 and this 3. And so this I can just cross out to 1. And then this 2 and this 2 are also just going to be 1. I'm doing that because I know it's going to end up being 2 divided by 2 and 3 divided by 3. Even though there's multiplication happening, PEMDAS tells me I can kind of do multiplication and division and flip their orders around. So this is also sometimes referred to as cross-canceling, if you remember that nifty phrase, but I often forget those, so I like to just remember what I'm actually doing instead. Now I'm left with a whole bunch of 1s, so I end up with the square root of 3 times 1 divided by 1, but really that just ends up being the square root of 3. And we are actually done with that problem. Okay, so that actually concludes section 5.4. We solved a lot of different problems involving sum and difference formula, and we also did double angle. A big part of these videos was simplifying fractions and simplifying radicals.